Moving now, please, to presentation from Department of Conservation. I believe we've got Dave Lumley and Michael Didoul here. Did I pronounce the second name properly?
Close.
Well, will you come forward and do it for me?
Certainly.
Are you bringing Dave with you?
Michelle's coming with me. So, kia ora koutou, thanks for the opportunity to present on the taupo fishery. This is Michelle Dudwell. He's our fishery scientist, and he'll be leading the presentation. Over to you, mate.
zooplankton is a big black box. As I said, we know reasonably well the phytoplankton, we know reasonably well the trout and the smelt, but we have some serious gap in our understanding of the zooplankton trophic level. And I'll come back to that later on as well. Now, from a mortality point of view, what we try to monitor is the loss of the fish. So the loss of the fish can be lost by predation or by competition, and one way to do some research about that is to look at stable isotopes and doing all sorts of different survey. Again, I'll come back on that. And also, one of the main one is the angling, because in Taupo, the trout don't have natural predators. The only real predators that they have is the anglers. They're shags that take the occasional trout, but by far the biggest predator is the anglers. So we want to have a good idea of what the anglers are doing. To do that, we approach them face to face. We interview them about trying to see some information about their satisfaction. That also allows us to understand how much pressure is put on the fishery in terms of hours spent on the lake or along the river fishing. And we also look at the anglers' behavior, because this is reasonably easy to understand what the fish are doing, but to understand what the anglers do, it's slightly more complicated. Now, this is a slide that I always present to every group that I talk to, because in a nutshell, that tells exactly the story, that gives us a really, really good idea of what's going on with the fishery in time. Now, we are fortunate to have this very, very long data series that comes back to the time where trout were first introduced in Taupo, which was in 1896. And since then, the anglers were keen enough to maintain some very, very clear diaries that were recorded all the fish that they had caught and the average size and so on. And using this set of data from the early days and then the trout data later on, we can actually follow the trend in the average size of the fish in Taupo that existed since 1896. So what we see here, there's two things. There's first this unbelievable size of fish that was that were caught in Taupo early in the last century, but then a general decline, but then also a very stable. It's a very stable fishery. It's not as dramatic as sometimes what we can read in the newspaper, especially during that time. Now nobody argues, we have been through a depression since 2005, but in fact, if you compare to what happened earlier on in the 1960s, the situation as far as the fish size is concerned was not any better than now, and that's something that anglers tend to very, very easily forget. They mention often the good old days, but in fact, that doesn't stack up.
So, mate, do we know why that big dip is right at the beginning? It's a huge dip size. Do you know what happened there? Was it an eruption? Or?
Which one? This one?
Yeah, the first one.
Well, you have to think about, as I said, a paddock which has only grass. It has never been anything that has been browsing on that paddock. And suddenly you put a flock of sheep or whatever on it. The size and the population of fish of sheep would explode. But then when there are so many sheep and not enough grass, the condition of the sheep goes right down. So that's what has happened then. When the trout were introduced, the lake has virtually only bullies and coral. There was no other fish species in the lake, and those fish had virtually no predator. There was a harvest from Maori, they were eating coral, but apart of that, there was no predator. So the trout, very quickly, they reached tremendous size, but they also very quickly depleted the supply of coral that existed in the lake, and as a result, the fish condition dropped dramatically. The managers at the time understood that there were too many fish in the system, so what they did then, they embarked on a very big, large netting project where they removed tens of thousands of trout out of the system that they were burying them or use them as fertilizer. And by reducing the number of trout that were in the system, the condition picked up again. But it didn't same thing, didn't last, and the condition dropped again. And that's when they realized that, in fact, the food supply was not suitable for trout in Taupo. You could not have a stable fishery if the main prey for trout was whakaaro. And at the same time, they had the similar problem in Rotorua. And in Rotorua, what they did, they introduced smelt. So smelt were introduced from the Waikato River in Rotorua in order to sustain the growth of trout. That was very successful. They did the same thing in Taupo. And since then, yes, it has been some fluctuation, but not as dramatic as before. Meaning that when the smelt are in good nick, the fishery is in good nick. We will see later that in fact it goes further than that. Now, there's one thing which has changed with in Taupo, quite markedly for the last 10 years or so, is that the bulk of the fish that are returning to spawn seems to happen later and later in the year. Early on, we had a very evenly spread spawning runs throughout the year, but now it looks like it's concentrated at the end of the year. So this is an important aspect because the river fishery in Taupo is based mainly on winter fishing. So the anglers fish on the lake during summer and they fish on the river during winter. But if the fish are not running anymore during the middle of the winter, then the fishing is not that great and the economy of the area will suffer. So why do we have that shift? Well, there are two possibilities. The first thing is that it's a genetic evolution or the angling. First of all, in relation to the genetics, what we know now, we have done 4-year studies to try to work out exactly where the trout that were introduced in Taupo come from. And now we know that, in fact, they were introduced from several sources. This is not one release of fish that has created the population that we have now. It's actually a mixture of fish coming from different places in California. Now, this is a really interesting one because this is far more by, it's not by good management, but by sheer luck. It's a bit like the discovery of penicillin because the scientist Fleming was messy, and that's how he discovered penicillin. So, similar thing with Taupo. The people who organized the shipment of ora from California to Taupo, they had actually a mixture. What does it mean is that there were some fish which were first introduced, that had a sort of an ancestral behavior in California to run early in the season, and there was another bunch that comes from the coastal rivers draining California that tend to spawn later. By putting the whole lot in Taupo, it evolved into a spawning run that was spread over a longer period. So that's really, really good. Now, and that's how we also discovered that these fish that are running early, yes, they are indeed different from the fish that are running late. And that's done by what's called the clock 1B gene, which is basically a gene that will define at what time the fish will start to run up the river to go spawning. And there are 2 alleles in those, without going too much in detail. There's 2 alleles in that gene, and the distribution of the 2 alleles will be defined if it is an early running fish or a late running fish. So, yes, there is an aspect of genetics, but then we were far more concerned as to know if effectively the fishing can be creating, let's say, a shift in timing of spawning rather than simply a genetic evolution. And every 5 years, we do an extensive harvest survey of the lake, where you have a plane flying over the lake and over the rivers. The plane counts how many boats there are, and then there are people on the boat ramps who are interviewing the anglers as they come back. We can work out the total number of hours that have been fished. With having an idea of the average catch rate, we can calculate the total amount of fish that have been harvested for every year. So we repeat that every 5 years, and what we can see is that since the 90s, the fishing pressure climbed quite high in Taupo, but then since 2000 it started to drop. So it's unlikely that the fishing pressure on its own is the main driving for this shift of spawning season. This is really good news actually, because if it would be the fishing that's responsible for shifting the timing of spawning, then we would have to do some serious regulation to try to control that, and that wouldn't go down very well within the community that relies on fishing as a subsistence. Just a quick one to show, because it has been a bit of a misunderstanding, I would say, in the newspaper regarding an experiment that we're trying to do. We are trying to see if by reintroducing in-Taupo fish that have been spawning, that are spawning early in Rotorua or in Mangakino, if we could actually recreate this early run of fish. This is a pure experimental experience. It has nothing to do with an overall strategy or a routine program that we're going to carry on in Taupo. So what we did, we released 5,000 little fish, which they come from Nongataha in Rotorua, but originally they're from Tarawera. Tarawera fish, they are from Taupo fish, so it's virtually the same thing, but the only difference is that they run early. So we take 5,000 of these, we inject them a little fluorescent elastomer behind the eyes, and we will see what comes back in 2 years' time. If actually these fish can come back at the time that we would like to see them coming back, or don't they? So it's a very small experiment. I put that one as well because it's another very important one. I think in my view this is probably the most serious one. What it tells you is that it doesn't really matter how many fish are in the system, the anglers are still able to capture them at the same rate. And that's a very important one, because this is for a similar reason, for example, that the collapse of the cod fishery in the Northern Atlantic was not noticed straight away, because for a long time we are relying on simply the catch rate to work out the health of the fishery. As long as the people still catch the same amount of fish per hour, she's fine, everything is sweet. But you can drive that to a level where eventually, poof, the whole thing collapsed, and you have missed completely the collapse of the fishery. So to tell you that, it tells two things: that we cannot rely on catch per unit effort to try to have an idea of the overall health of the fishery, and more importantly, if you, for example, there is a push in the community to tell us, oh, but you should put more fish in the system. You should put, let's put more fish in the system. The reality is that if you can put as many as you want, to make a difference in the catch rate, you would have to put zillions of fish in the system, and the food supply simply doesn't exist in the lake, and also it would be extremely expensive to embark on. Logistically, we don't have the resource, neither financially nor as far as the infrastructure to do such a project. So, as I said before, the lake is the real engine, and that's probably a very illustrative picture that shows what's going on in the lake. There is tremendous current in Lake Taupo, and this current is like a big soup bowl where the whole thing gets stirred up. The grass, to come back to the phytoplankton image, the phytoplankton cannot swim, so the only way that it goes around the lake is being taken by current, and the current will depose phytoplankton in one area, the zooplankton will try to find it, the smelt will be behind, and the trout will be behind. So it's a real dynamic system, and we know that the trout needs to do an awful lot of swimming in the lake in order to be able to catch enough smelt to grow. We know, for example, we had one that in 9 months, that fish swam more than 5,700 kilometers in 9 months just to survive. Here I've put something, it looks a bit messy, but in fact from an ecological point of view, it's a very simple trophic food chain. You have chemical elements, and I have put a circle around nitrogen because that is one that comes again and again. And in Taupo, nitrogen is the limiting then this is the important one, is that all that what's produced here eventually get recycled at the bottom where the bacteria give them again available and the whole circle goes around. So there is enough nutrients in the system, but sometimes the bacteria and the mechanism at that level doesn't occur completely, so you don't have all the nutrients that we turn into the system. We don't need to have more nutrients coming in the system because it's not going to make jack a difference. It's going to make things worse, actually. So how do we calculate that? Well, it's a very easy, very simple way to do it.
Yeah. It looks.
Another way to look at it is in terms of biomass. That's the grass, phytoplankton, that's the zooplankton, that's the smelt, and that's the trout. So to produce that much trout, you need an awful lot of grass. Generally, because Taupo is a very simple system, there's not many fish species, it means that the transfer of energy from the bottom to the top is not that good. It's far better in the tropical system, for example, where there is far more species, and if one species doesn't work well, there's another one that's going to take the opportunity to jump in. In Taupo, you have one level that doesn't work properly, and the whole thing crashes. Now, I said that sometimes the nutrients don't get available, and this is when it doesn't. This is the monitoring which is done by Environment Waikato that has been going on for quite many years now, and that tells you the difference in water temperature between the surface and the bottom, and that's important because this is when the water has the same temperature that it can actually mix and bring all the nutrients back in surface. Sometimes the lake doesn't mix, like for example in 2005 and 2006 for a very short period. So that means that because the lake didn't mix, not the whole lot of nutrients was available in the trophic chain. It's not that there was not enough in the system, but it didn't get fully recycled. Okay, so what's going on with the grass? What's going on with the one way of measuring how much grass is in the lake is to actually look at the chlorophyll. The chlorophyll is the green pigment in the grass, so if you measure the quantity of green pigment that you have in the water, that tells you how much grass is in the system. So early on with the urban development, the intensification of the land use in the catchment, the grass, the chlorophyll started to pick up. But since 2000, with the limitation on the nitrogen input in the lake, it looks like it's working because it's stable now. It's not going up anyway, which is a good news. Now, something far more difficult to understand is the zooplankton. What's happening with the zooplankton? As I said, this is where the big box is in our big black box is in our understanding. There is an overall decline in zooplankton that started to occur since the 2000s, and one particular species, which is one of the main food of smelt, it's almost gone since 2007 and 2009. And this is really where we don't understand. We're really trying hard to figure out what the hell's going on there. And that's basically the bulk of the research that we're trying to put in place regarding trophic food chain in Lake Taupo. If we can understand that, it will be very important because I'll show you why. We know now that when there is a lot of zooplankton in the system, there is also a very good survival of fish when they spawn after they have been spawning. And that's important because in Taupo, if you need to have the population of trout remaining at a stable level, each female must spawn more than once. It's not like salmon. Salmon, they will spawn once and they all die. So they are very productive. With spawning just once, they can sustain the population. Trout are not so productive, and each female needs to spawn more than once. So it's very important that the survival between the time it spawns for the first time and the second time is actually good, because that will increase the chances of surviving twice. That means keeping the population going. So if we can understand exactly, well, not exactly, because I guess we will always have some unknown, but if we have a good understanding of what's going on with the zooplankton, that will be very helpful to predict what will be the survival of trout from one year to the other, and also to anticipate what we can, how we're going to communicate that to everyone. Now, another way to put, it's not a very good picture, but zooplankton, when it's very, very abundant, trout eat them. And I had Dave came back with a trout and he said to me, look, there's something really strange in the gaps of that fish. What is it? So we had to look under the microscope, and in fact it's zooplankton. So when zooplankton is plentiful, trout will have a go as well. Directly, they will jump the smelt level and they will have a go at zooplankton. And I just finished the echo sounding survey of the lake, and there is absolutely cloud of zooplankton in the lake. So everything points to a very good season this year as far as the condition for growing fish is concerned. Now, will it eventuate and turn into very numerous large trout? It's a bit early to say, but this is a good sign. This is a very good sign. So those guys, bigger picture. It's a Daphnia. We don't know exactly the species yet, but this is a pregnant Daphnia. So you have the eggs of that little zooplankton, and they're about 1 millimeter long, those things. So very rich, because the eggs will be full of fat. It's a very energetic food supply for trout. And trout at the moment, they are in exceptional condition because they're feeding on that. And that's also, you can understand why trout turn orange when they feed on a cura. This is a miniature cura, if you want. It's a crustacean. So, we've heard that it may be good to have more nutrients. Some people believe that it may be good to have more nutrients in the system. Well, the only thing that it would do is basically turn Lake Taupo from blue to green. I don't think it's something that people want. Smelt. To try to figure out what smelt are doing in the lake, until recently we didn't have the technology to do that. Now we have it. And we carry out 2 surveys per year where we take 100 kilometers of transect, 7 transects across the lake, parallel to each other, and we actually count everything we can. Count the trout, count the, well, not count, but make an estimation of the density of smelt in the lake. You also have seen that we mentioned that this is probably the most formidable predator of rainbow trout. This is the brown trout, and we want to understand exactly the role of brown trout in the fishery, because, as I said, potentially they can be a serious predator. It's not good or bad, but it's just a matter of trying to understand to what level brown trout can be a danger to rainbow. And to do that, we actually make some stable isotopes analysis, which in a nutshell it would be to say that you are what you eat. So if you eat a lot of one thing, you will have a signature of that in your flesh, and that's exactly what we do. We take some muscles and some liver from fish. The liver will tell you the signature of the isotopes in the liver will tell you what the fish has been mainly feeding upon during the last week, and in the muscle during the last months. And the closer the different species are, the more they rely on each other for their prey. So yes, the brown trout are close to rainbow, and they may well be consuming a sheer number of them. That doesn't mean, like it has been previously stated in some newspaper, that we're going to embark into a culling program and getting rid of the brown trout. It's ridiculous. Sometimes you also hear that catfish are a problem in the system. So what I've done here is that we have been monitoring the abundance of catfish for the last more than 10 years now. And I have put here as an indication of the abundance of catfish the number of fish that we're collecting in the net through the time. they are not threatening trout, is that if at the same time, if we put the number of trout that are actually going through the wiper truck, which tells us the overall number of fish in the system, well, I would argue that's the other way around. You know, the year where we had the highest number of catfish in the system, we had also a pretty good population of trout. Same thing here. So, you know, that really, if catfish would be such a problem for the fishery, then you wouldn't have that sort of thing. And now there's also some good news. If you go back to the number of fish, yes, we have been through depression, but we are on the right track. And the point here, 2012 is not finished yet because we have another 3 weeks at least of really good run. We expect to sit at the same level as we had about 3 or 4 years ago. So, finger crossed, it looks like the depression is behind us. And even more encouraging, this picture was taken early in the season, so that's early running fish. That was in May in the ratou, which is a tributary of the Fitiko. So again, this is a really good sign. And that's it. Thank you very much.
Any questions from councillors? Councillor Mincher.
So is the aim to increase the average weight rather than the numbers of fish? Do you know what I mean? Like, is that balance that you're trying to achieve, or?
Well, that's a really good question, because generally what we found in the lake, in the truck data, is that when you have a good season, a good year, you have a lot of good fish. If you have a bad year, you have not many fish, and on top they are not good. So again, everything points to the lake. So I guess to answer your question, if you tackle the number, the condition is already included in it. But the big problem is that it's in the lake. What in the lake is actually creating this? And we know there's some very weird things going on in the lake. Unfortunately, until now, we haven't had a chance to get enough resources to look carefully.
Thank you. Awesome presentation.
Any other questions from councillors?
Yeah, thank you. Very informative. You said that there's plenty of zooplankton, or this year there's plenty of zooplankton, but not too many smelt. Do you know? Because they feed off the zooplankton.
Yeah. Well, that's interesting, because I made exactly the same comments, because all these fish that are full of plankton, they were mainly caught in the southern end of the lake. And yet, some reports of the western bays are coming back saying that they're catching fish which are loaded with smelt. But my gut feeling is that smelt swim a lot, so you need to trout, even though they are very good swimmers, they need to chase them to get them. Zooplankton are easier. It's a bit like a whale. They open their mouths and they cream the whole lot, and you can see I didn't take the echogram, but it's thick. It's literally millions of them per cubic meter of water. But it will be interesting to see how much, and the stabilizer though should tell us how important the zooplankton is directly for trout.
Councillor Kirk.
Yes, thank you. Just one question. When you talked about the nitrogen before, were you saying that the nitrogen was inhibiting, or that they needed the nitrogen?
For the food chain?
Yes.
Well, the nitrogen quantity will determine how much productivity is possible.
So if we're taking...
That doesn't mean that it's actually occurred, but that's what's limiting. If you have a certain amount of nitrogen, you cannot have more grass than that. If you have more nitrogen, you can have more grass.
So if we're taking nitrogen out of the lake, or reducing the amount of nitrogen going into the lake, then that's going to...
No, because you cannot really take the nitrogen out of the lake. What you can do is stop putting nitrogen in the system.
Right.
But nitrogen, it's included in the flesh, it's included in the... This is not like you can conceive it and take it out of the system.
Okay. So if we're stopping nitrogen going into the lake, what effect does that have on the food chain?
It won't have a huge effect, because, as I said, it's far more the way that the whole thing is recycled rather than the quantity per If the productivity occurs, then it will happen what's happening in Rotorua or in another lake. It will create algal bloom that will drop the concentration of oxygen and that will kill everything.
Any further questions?
Yeah, sorry.
Councillor Truman?
Does the Department of Conservation, do they look at the river as well, like the trout supplies on the other lakes along the river, or is it just the Taupo?
No, that's the only place of Taupo. And Otamangako, which is the other catchment. But a part of that, DOT doesn't take care of doesn't manage any fishery except for
Fish and game. Okay, there's no further questions.